So let's see here, and here is the code. You see the temperature, these are digital value of the temperature. And let me pull the main stuff. Yeah, here so you can understand what's going on here exactly. So my steps, the lab is here. The lab is here. What the heck? So the lab, yeah, here. Lab is here. Now you can understand what's going on exactly. So this lab or the project, this is project for electrical and electronic engineering student. And let me zoom in. So here the goal is to light up a sequence of LED based on the temperature, from room temperature to anywhere we are able to go, hot or cold. The LEDs are all on at the highest temperature and less in between depending on the value of temperature. If you want it to work with your finger for heating it up and a fan for cooling it down, then your numbers will be close to room temperature. If you want to heat it up more with a soldering iron or can of compressed air for cooling, then your numbers will have to be speed out more. And the schematic is here. So here this guy is the sensor. Its name is MPC 9700, and this guy is the pin 3 is connected to the ground and pin 2 is connected to the Arduino board. Here this guy is AX, and we have two resistors to control the sensor. So we can use voltage divider. So right now I'm using 4K and 2K. The temperature sensor used in the MPC device, which operates from -40 degrees centigrade to 125 degrees centigrade, corresponding to 0.1 volt to 1.75 volt. So here we need, here at voltage divider we need temperature like 1.75. So I think let me calculate the value of the sensor. Here you can see the value of sensor. Let me just by voltage divider plus minus, this is 5 volt, the supply from the Arduino board, and this is one of the resistor R1, and this is one of the resistor R2. And I think I have 2K, 2K, and other is 4K, I think. Let's see. We are finding voltage at R1. So 5 volt into 2 plus 6. So 3. So we are getting 1.67, right? Volt. I mean, we can, I told you, like, we need at least like from 0.1 volt to 1.75 volt to operate the sensor. Right now you see the values are going. I mean, these 3 LED are at room temperature like 20, and these are on higher temperature. You see, these are on higher temperature. Let me pull out the Arduino. Here, look at the temperature, how the serial monitor is running here. These are serial monitor, the values in digital, 392, 393, and let me show you here. So you see right now we have 393, so which is 393 like 26 degree centigrade. To turn on the other LED we need at least 38. So in digital we need 450. These are ADC values at each level. These are sensor voltage from chart formula. So hope you guys are understanding what I'm telling you. Look at here right now. How many 4 LEDs are turn on? 4 LEDs are lighting up, and 4 LED. Look at the first LED is like this. 4 LED like 26 degree. We have just 389 degree. We need more degree. The temperature is still going off. The temperature is going off here. Look at here. You see, sensor is controlling. Like, you see the all LED right now it decreases. I mean the temperature goes down. That's why these all 3 LED turn off. These are all controlled by the LED sensor. I mean my body temperature is more, That's why when I pull my hand out from there, the LEDs goes turn off. You see, when I bring my hand here, look at here. You see. So this guy is here. We have 5-volt supply, and this guy is ground. This is the analog pin. Now the temperature is rising. You see, 400, 399, 400, 399. When I bring my hand here, the temperature goes off. I mean, what we need here? I mean, the maximum, the 450. We have 450 here. Look at here. See, here is just 450. It takes time, I think. It takes time to warming up, I mean, to absorb more heat for the LED. Right now, how many LED are turning on? 6 LED. So let's see. For the 6 LED, we have 490. Here we have also 420 like. So I mean, the temperature is still rising. So hopefully this is going to turn on all LEDs. And let me tell you about the Arduino board. So this is at Mega 328. This guy, you see the microchip, it's a single chip in this board, and it's the microcontroller, the AVR microcontroller at Mega 328. And these are the digital pins. And these are analog pins. These are like power supply, and these are these. And this is the reset button. You see the red one. This is the reset button, and this is the built-in LED. This is the turning on LED. I mean the power is supplied. You can see when this light is on, I mean your Arduino board is on. And this is the transmission line. This is the receiver one. And like this is the power supply from the PC. Let's see. Right now we have 427 voltage. We need 435 and 450 to turn on all LED. we need to wait at least like, I think maybe like 5 minutes, I think, because it's the sensor is warming up. I mean, sensor, the LEDs. Look at, right now we have 440, 435, like 7 LEDs are turned on. We just need to turn on the last LED. The we need 450 value for this. It's really cool, fun project. I mean, you guys can also try doing these stuffs. You, for this project, you need the Arduino board and a breadboard, 8 LED, 8 200 ohm resistors, and one like 4K, one 2K resistors, and we need one IC, which is the IC is temperature sensor. No, this is the MOSFET temperature sensor, and the IC is here. The IC name is shift resistor. Let me show you what the name. I forgot the name. So IC is 740 SC595. And this is also called shift resistor, because this is working on the basis of interrupt. We just need one LED to turn on. Then I will show you how to turn off this LED. So turning on the LED, it depends on the temperature, and to turn off we need to decrease the temperature. We need to fan out. If you want to look at the code, I will show you here. So code is here. The code is here. This is in C. So we need to define the variable. Like here I define the constant into SCR. This is the data, serial output to shift register, and the other is constant int latch. This is the shift register latch pin, and the other one is clock 10, and these are the which pin we are using here, like 8, 9, 10. These are the digital input, digital pins. So here I define also like int ADC value, and I have defined the temperature sensor, which is analog input A1, and these are the values int sequence 9, because we have total like 9, 1 2 3 4 5 6 7 8 9. So 0 0 is at 0 0 the LED are off. One LED is turned on, 2 LED, 3 LED, 4 LED, 5 6 7 8. Int n, describe the position of LED. So here in the setup loop I have defined the pin mode, the SCR output, the latch, clock, like these guys we need to define. I mean, we need to assign the output pin, and this is the serial.begin 9600, which is here. You see serial, which is showing the input and output. I mean, which is showing the exact temperature in the printing mode. And here we have also in void loop, in the main loop, I have defined the analog reference external and the value. This is the value, which is reading by analog read temperature sense. This is the system.println value, which is print out here. And we are going to check these LED by using the if statement. If value is like greater than or equal to 450, then the last LED, the 8 LED is turning on and turning out. So this is the digital write for the turning on, turning out. This is the shift out, SCR, clock, LSB first. This is least significant bit. I mean the first, and sequence 8. This is the position of the LED. Else if otherwise this is going to turn on. This so and so on. Here we define like everything here, and this is the delay, which is 200 millisecond, like 0.2 second. Still we need one to turn on, because still we have just 440 temperature. We need to turn on the last one, we need 450. You see, when I touch this one, the temperature goes down. That's why this is the sensor. Now I'm going to decrease, turn up this LED. I can use this bottle. So this is the alcohol, I think. Let's